Hello, all. Welcome to yet another enriching session on food chemistry. In today's lesson, we will be discussing interaction of water with non-polar molecules. So let's get going. Food not just contains ions and non-ionic molecules, but you also have hydrophobic materials such as non-polar groups of proteins, amino acids, fatty acids that are capable of interacting with water. This reaction is unfavorable thermodynamically. Why is it unfavorable thermodynamically? Because delta G, which is called as change in Gibbs free energy, is greater than zero, meaning it is positive. So you need to supply additional energy for the reaction to proceed. Gibbs free energy is nothing but it is how much amount of energy is available to do work in a closed system when you keep pressure and temperature constant. It is used to determine direction and extent of chemical change. Now, whatever delta G increase you see is because of decrease in entropy. And why is there a decrease in entropy? Because when you combine water with these non-polar objects, they tend to interact with one another and form something called as hydrophobic hydration structures, which are considered to have increased order. That's why you see a decrease in the entropy of your system. Now, the innate property of system is to move in a direction of thermodynamic equilibrium. So, as a result, what it does is that in order to compensate for the loss of entropy, the system modifies itself in such a manner that there is less interaction between non-polar groups and water. Now, how is this achieved? How is the system modifying itself so that it can hold less water in relation to non-polar entities? For this to happen, two distinct non-polar groups that are present, they come together by means of hydrophobic bonding to form a cluster. And then you have water enveloping this non-polar entity in a cage-like structure that's what is seen here. They are called as calcitrate hydrates. And what you have to remember here is that if such a structure is formed, there is decrease interspatial space between the non-polar entity and water. However, what you have to remember is that you have hydrophobic bond which is formed, but the energy that is required to break this bond is just 2 kilojoule per mole. After talking about interactions with different molecules, it's evident that the presence of a mix of polar and non-polar groups in the real food system can make interactions fairly complex. So it's not just one interaction that we will study in food system. It is combination of all these interactions that will ultimately determine the chemical changes and the physical behavior of food. Thank you for staying with me through the lecture. In case you have any queries, please feel free to put them in the comment section and I'll get back to you as soon as possible. In my next video, we'll start with discussion of water activity and its importance in food. Until then, merci beaucoup.